some configurations of EBS volumes. We have things such as RAID, which stands for Redundant Array of Inexpensive or Independent Disk. So these are just configurations of different EBS volumes, which these are just different ways in which EBS volumes are put together to achieve different aspects, such as performance, capacity, speed, and redundancy. The very common RAID types, we have RAID 0, RAID 1, RAID 5, and RAID 10. Those are the common RAID types we have. So it's just combining different EBS volumes for the speed, for the performance, the capacity, and for tolerance. So the very first one we have is RAID 0. Now, what is RAID 0? That is having two hard drives in which whenever you store your data to your hard drive, the data is split evenly between those hard drives. Let's use the example, the statement, welcome to RAID day. So we have two hard drives, this in the case of a RAID 0. So what happens is once you try to save this statement or this data in this hard drive or this RAID configuration, your data is split evenly between those two hard drives. So you have welcome to RAID day. So your data is split evenly. So for example, you have two 1 terabyte drives. That gives you a total capacity of 2 terabyte worth of storage. Such you have more capacity and that gives you more speed for the RAID 0. So you have ultimate speed for the RAID 0. Now the downside to this is you do not have redundancy. So if you lose any of this hard drive or if any of this hard drive fails, you lose half or all the data you have stored within this RAID configuration. So RAID 0 provides you speed, but it doesn't provide you redundancy. And you have double the capacity of the single hard drive you use. So you have 1 terabyte worth of hard drive and another terabyte. That gives you a total capacity of 2 terabytes. So that's how the RAID 0 functions. Now, next we have the RAID 1. Okay, so the RAID 1 is just mirrored disk. So let's say you have 2 terabytes, each 2 hard drives, each with 1 terabyte. So that gives you 1 terabyte and 1 terabyte. So what happens is all your data is stored into one hard drive, and the other hard drive is a mirror image of the first hard drive. So you have, using the same statement we had, welcome to RAID day, that is stored in hard drive 1. And your hard drive 2 is a mirror image of that hard drive. So with this RAID 1, what you have is, you have redundancy. So you have improved availability. So if one hard drive fails, you can use the other hard drive to recover the failed hard drive. Okay, but the downside to this RAID configuration is it might slow your performance. You do not have speed as compared to the RAID 0. So with the RAID 1, only one hard drive is needed for recovery. But in this RAID configuration, you're limited by the speed and the size of the slowest disk you have or the slowest drive you have within that RAID configuration. So with RAID 5, you use a minimum of 3 hard drives. With RAID 5, you use a minimum of 3 hard drives. Now, this is a widely used RAID configuration in industries or in enterprises. Now, with the RAID 5, in this example here, let's say we're using the statement Tuesday revision session and EBS RAID here. So we're using those two statements to demonstrate this. So with the RAID 5, you have striped disk with distributed parity or checksum. That is called backup. Checksum or backup. So what happens is your data is split evenly among your hard drives. So let's say we have 4 hard drives in this case. your data is split evenly between 3 of the hard drives, and 1 of the hard drives is used to store the entire data as your backup. So using the statement Tuesday revision session here, for the first case we have Tuesday goes into the first hard drive, revision goes into the second hard drive, session goes into the third hard drive, and the entire statement or all your data goes into the last hard drive. That is your parity over here, or your checksum. And now for the next one, what happens is your checksum rotates, or your parity, the drive in which it is stored, rotates as you keep storing data onto it. So for the second case, using the EBS RAID here, so you have EBS stored into hard drive 1, RAID stored into hard drive 2, and EBS RAID here goes into hard drive 3, and here goes into hard drive 4. So with this RAID configuration, what happens is your parity is rotated within, or is alternated within your hard drives. So if you kept adding data onto this RAID configuration, the next, your parity will go onto hard drive 2, and lastly, it will go onto hard drive 1, while the other data is split, or while the data is split among the other 3 hard drives. So that is how RAID 5, that's how it operates. Now, the good thing with RAID 5 is you get both speed and performance. You get speed and performance with RAID 5. With RAID 5 as well, if a single drive fails, you have your parity, which you can use to recover the failed hard drive. So let's say for the case of the first statement we had, Tuesday revision session, let's say hard drive 3 fails. We can use the parity in hard drive 4 to recover the session drive, or the hard drive 3. And likewise, if we're using EBS RAID here, and let's say hard drive 3 fails, hard drive 3 that contains the parity for EBS RAID here, if that drive fails, you can use the other 3 hard drives to recover hard drive 3. So that's how EBS, or the RAID 5, will operate. The downside to the RAID 5 is once you do this and you have a parity, that increases, or that adds a certain level of latency to your system. So that's the reason why it is not allowed in the cloud yet. Lastly, if for this RAID 5 we had the 4 hard drives that were each 1 terabyte, you have a total of 4 terabytes. But the downside is only 3 terabytes are used, or gives you the storage of 3 terabytes, because 1 terabyte of any of the hard drives is used for parity or for backup. Okay. And lastly, we have RAID 10. RAID 10 is just a combination of RAID 1 and RAID 0. So we said RAID 0 was combining the two hard drives to give you the capacity, and RAID 1 was a mirror image. So one hard drive was a mirror image of the other one, and that gives you redundancy. So RAID 10 is a combination of speed and redundancy.